Hi folks! I'm going to talk about a little electrical component for measuring temperature called a thermistor. I originally needed it for measuring the water temperature in a set of experiments, determining if cold water boils faster than hot. But just for fun, I also got it to turn on this PC fan when the heat was too high. What's a thermistor? A thermistor is usually a ceramic or polymer material with two wires connected to it. The key is that the thermistor's resistance changes with temperature. With some, the resistance increases as the temperature increases. Those are called positive temperature coefficient or PTC thermistors. With others, the resistance decreases as the temperature increases. Those are called negative temperature coefficient or NTC thermistors. I couldn't find a thermistor locally, but some quick research turned up that automobile coolant temperature sensors are just thermistors in a protective case, which was a good thing since that saved me having to make a case of my own. With this one, there's only one obvious place to connect to, this threaded part. So where do the two thermistor wires go inside? Well, one goes to the threaded part and the other goes to the brass case. So I wrapped one wire tightly around the case, and after attaching a ring terminal to a wire and finding suitable nuts, I attached another wire to the threaded part. I then connected up a meter and put it on the resistance scale. Remember, the resistance changes with the temperature. I put my fingers on the probe part and it started to heat up. Sure enough, the resistance on the meter started to decrease as the temperature increased. So it contains an NTC, or a negative temperature coefficient thermistor. To be useful, I needed to know what resistance matches what temperature. Unfortunately, I couldn't find a resistance temperature table for this particular one, so I had to make my own. To do that, I prepared a tall container, this soda can with all the paint sanded off. I filled it with water and put the probe part of the sensor in the water. I also put in my kitchen thermometer. The long length of my thermometer is why I went with a tall container. For my purposes, I needed to know the resistance to temperature values for temperatures near the freezing point of water. So I put the whole thing in my freezer until the thermometer read near 0 Celsius, or 32 Fahrenheit. Then I took it out, connected my meter to measure resistance, and put it on my stove heating element. I then started recording the resistance on the meter and the corresponding temperature on the thermometer as the stove element heated up the water. I stopped once it reached boiling, which is 100 Celsius or 212 Fahrenheit. And here's the chart drawn using the data from my table. As you can see, the resistance decreases as the temperature increases. You can also see that it's a curve. The whole reason I'd gone through this process was to do some experiments to determine if cold water boiled faster than hot water, as some people think it does, and to find out why that myth might exist. That resulted in this graph of water temperature as it was heated up over time. But that's a whole other topic, which I cover in another video I'll point out later. Here's the fun I had making a PC fan turn on when the thermistor gets too hot. First, here's the circuit without the thermistor. It's very simple. The positive from my homemade power supply goes to the positive of the fan, and the negative of the fan goes back to the power supply. When I turn on the power supply, the fan starts spinning. Now here it is with the thermistor. The positive from the power supply goes to one end of the thermistor. The other end of the thermistor goes to the positive of the PC fan, and the negative of the PC fan goes back to the power supply. But this time when I turn on the power supply, the fan doesn't start spinning. That's because the thermistor is nice and cool at room temperature, and so it has a high resistance. The fan needs a certain amount of electrical current going through it in order to spin. But the higher the resistance in the thermistor, the lower the current is going through the fan, and the resistance of the thermistor is high enough to make that current too low. Now I use this hairdryer to heat up the thermistor. That causes the thermistor's resistance to decrease. As it decreases, the current increases. And when the current's high enough, the fan starts spinning. Notice that the fan is blowing on the thermistor, making it cool off more quickly. Here I'm showing the airflow direction using this tissue paper. As the thermistor cools, its resistance increases, and that causes the current going through the fan to decrease. After a minute or so, the current is too low to keep the fan spinning, so it stops. Well, thanks for watching. See my YouTube channel, rimstar.org, for more videos like this. That includes the video containing the experiments to test if cold water boils faster than hot water and why people might think that. Another on how to power a compact fluorescent light using just 2 AA batteries. And one on how to make a solar panel out of transistors, in this case to power a calculator. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you in a bit.